I'll go with dog.
All right, so this is 2-4. We'll call it B since we did 2-4 last week. 2-4B. Variables on both sides. Variables like, you know, the A, B, C, D's, all those, X and Y. Now, the key word here is equivalence. Equivalence. What does equivalence mean?
Equal.
Equal. Sure, that works. Equivalence. The same, right? So that's kind of our key word. So we're trying to make both things equal. So if we have variables on both sides, variables on both sides, we're trying to make them equal. Okay? So some equations have variables on both sides. You've already seen them. You don't have to write that down. Just a little note. Here's an example of an equation with variables on both sides. It's the same variable, right? D is the variable here, but it's on both sides. So we have 8 plus 4D equals 5D. The number one problem with these is where to start. People are like, what do I do first? What do you do first? Who has an idea? Raise your hand. What do you do first, DJ? Subtract 8 from both sides? But now I still have variables on both sides. Bryce?
Combine like terms or like subtract from both?
Sort of. Pam?
Subtract the 4 from the 4 and then the 4 from the 5, so then 8
The 4D? Yeah. So what we want to do, you guys, here, and this is why I say it's hard to do this, but we want to get the numbers on one side, like the whole number without a variable, and all the variables to the other side. And it doesn't matter if you go right or if you go left, but you just pick the easiest way to get there. Some people, if they have a negative on the left, they want to add it because they like adding negatives, so they'll move that. Some people don't even care. They're like, I love negative numbers. I'll do them all day. Some people want to get rid of the fraction first. Other people are like, I love fractions, right? All of you? Yeah. Okay, so you're right. We subtract 4D from both sides. Okay, that will give us what? 8 equals what now? 1D. So really that's the same as D equals 8, correct? You follow me so far on that one? Okay, so D equals 8. Are we finished? Are we done? No, what can we do? Plug it back in. You should do this, especially on these problems. Especially. So if I plug it back in, I'm going to put 8 wherever D was. 8, and I always use parentheses, and you should too. Parentheses are like your best friend here.
Who's that?
So if I plug in 8 wherever D is, that would be 8 plus 4 times 8 equals 5 times 8. So that's 8 plus 32 equals 40, and 40 equals 40. Last time I checked. Yes? Can you get 100% on the quiz? Can you get 100% on the test? And the test is actually easier because it's multiple choice. A lot of it. Okay? Now, here's what happens when we have numbers and variables. See, the last one I just had an 8 on one side. Now I have variables on both sides and numbers on both sides. Now you'll have to make a choice. What do I do first? What should I do, Jenny?
Subtract the smaller variable.
Yeah, I think that would work. So if I subtract 4n, then what's the second step? What?
Subtract 4 into the other side?
Yeah, and then after that, what should I do with the 1 and the negative 5? Or the negative 1 and the negative 5?
Yeah.
Add the 1 or add the 5? Let's see. These are things we have to think about. So if we subtract the 4n, which Jenny's right, then we're left with that, right? 2n minus 1 equals negative 5. Now what do we do?
You add the 1 to the 5.
Yeah. We've done these, right? These are simple two-step equations. So we add the 1 to the negative 5, and we get negative 4. We divide, and we get negative 2. Are we finished?
Yeah.
No.
Maybe.
Plug it in. So if we check, we plug in negative 2 wherever n was. Plug it all in. Negative 2 times 6 is negative 12 minus 1. Negative 2 times 4 is negative 8 minus 5. And they both make negative 13. You see how they're equal? Equivalence? That's what we're going for. This is why it's absolutely necessary, 100% great idea to check. Because if you don't get them equal, you did something wrong, didn't you? Okay, I want you guys to try this one in your notebook. This 8a equals 5a plus 21. We'll start off simple. So I'll give you a couple minutes to get that one. Make sure you check your answer. Okay, did we get an answer? Yeah? Who thinks we got an answer? You do? What'd you get, Addie?
I got 7.
7. Anyone else get 7? Wow, that's pretty good. See that many hands go up. So the answer is 7. Anyone need to see that one worked out? Or we're good? So we subtract the 5a and get 3a equals 21. Divide by 3 and we get 7. Easy one, right? Okay, try this one. 3x minus 7 equals 8x plus 23. You have to decide, what do I do first? What makes more sense? got an answer? You sure it's right? You checked it? You sure? Marin, what'd you get? Good. Who got -6? You're right. -6. So what'd you guys do first? Did you subtract the 3x first? Did you add the 7? What'd you do? You subtracted 3x, right? And so you got 5x plus 23 on the right side? And then you subtracted -23, like the -23 and the -7 make a -30, and then divide by 5. Do you think you could do this on your own?
Yep.
Maybe. Maybe. Okay? They're obviously going to get more challenging. Remember those problems I gave you the other day, and they had like brackets and all kinds of distributing and all that? You're going to get that eventually. Not like today, but eventually you'll get stuff like that, okay? So it does build. All right, any questions on that? Yeah.
Like, after we got to like 5x,
Uh-huh.
the -30,
Yeah.
What
Divide by 5.
where does the 5 come from?
That comes from the
Oh.
8x minus the 3x. Yeah. Good question. It is confusing, right? Yeah? Okay. Now, 2-5 is pretty similar to the 2-4s, except that we're going to have a couple extra things that happen. Let's see. Okay, so basically 2-5 is still multi-step variable on both sides. And you'll recall this kind of equation with distributing. If you know that one, you don't need to write it down, but I put an example just to remind you. With the distributing, and remember there were shortcuts too, like you didn't have to do the rainbows. If it was divisible, you could divide. Did the sub show you that? So, or did I show you that? I can't remember. I did. So let's see, 420 divided by 15 is 28. So I could have done the shortcut there. I didn't, but I could have. Sometimes shortcuts are more confusing for people, right? But if you see them, you should use them. But either way, you'd still get 8. So that's just a quick review. If you need the example, you can write it down. If you got this, that's fine. Your book, for whatever reason, does not teach the shortcut. So if you're looking in your book at the examples, you won't find the shortcuts. I don't know why, but they don't. So when you look at my examples from last week, they're still the same examples from the book. It's just that I put the shortcuts in. Okay. This one is just straight out of the book, though. All right. Any questions on how we did that? The rainbows, 15 times 20. We're good? You were all here that day? Okay. All right. You weren't? So if you check, it works out, so you don't have to write that, but I did. This is the important stuff from section 5, so I'm going to go right to that. The numbers of solutions. We're going to get different answers now. You thought, oh, great, I get x equals 2. I can plug it back in and see if I got it right, huh? Uh-oh. Now I'm throwing you a loop here. Here it is. There's different numbers of solutions. Yes?
How did you get the 300 up there?
I did 15 times 20. Okay.
Oh.
Yeah. So sometimes we're going to get no solution. Uh-oh. And then you're going to do the problem and you're like, wait a minute. I keep getting a number equals 0. Or I keep getting 2 equals 3. What's happening there are the variables are disappearing. Variables are going away. They're being subtracted or added or something's going on, and all of a sudden you don't have a variable anymore. And you keep going back and you're like, wait, where'd my variable go? And you're driving yourself crazy. But if you're doing it right, it just means there's no solution. And they call it, another word for it is called null, N-U-L-L, set. Null meaning like none. It's Latin, I know, because I took Latin at Fresno State, and I think I got an F. But it's from the Latin word. Null. You've heard of the word nullify? Have you heard that word?
No.
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 No future lawyers in here? Okay.
Nope.
Trust me on that one. Alright, so that happened because obviously I would subtract the 3x and then I would get 4 equals 0. Okay, no solution. You can, when you get one like that, you should double check anyway that you did it right. Like just do it again. Make sure. Sometimes you'll get ones like this where it's one solution, and we've been doing those over and over, right? One solution. We get an answer, we can plug it back in, and it works, and we know we did it right. This is most often what we get. Okay? And then the last one, so I have no solution, one solution. What do you think the last one is? Multiple, right? Multiple. And that we call infinite solutions. I abbreviated because I got tired of writing. So you get something like that. You get 4x plus 2 equals 4x plus 2. When you subtract the 4x, the variable goes away. So you're left with 2 equals 2. Does 2 equal 2?
No.
Yes. So if you get a number equals a number and they're the same number, then you would say that has infinite many solutions, or infinite, or you could write identity. Identity just means it's the same thing, right? Identity, 1 equals 1, 2 equals 2, stuff like that. So I gave you more practice today when you do the practice part in this section because I wanted you to see you're going to get more problems like that. Okay? They're also on the quiz, and they're on, actually I don't know if these ones are on the quiz, but they're definitely on the test. You're going to get one where it's like no solution, one that's infinite. You're going to get that. So keep that in mind. Alright, so here's an example, and I'm not going to tell you which kind it is yet. I'm just going to go through the steps here. Does this look kind of ugly?
Yes.
Yeah, this is what I mean, how they just become bigger and bigger problems, and you just look at it and you're like, what do I do first? I'll tell you. You distribute first. Distribute. So we have to do our rainbows. 8 times 4, I'll even draw them for you. Rainbows. And then 8 times negative 2x. And then 4 times 3 and 4 times negative 5x. Yes?
We did something like this in our practice.
Uh-huh. Yep. You did. So here, I distributed. Do you trust me? Do they look right?
No.
8 times 4 is 32, right?
No, I just don't trust you.
Okay. 8 times negative 2 is negative 16x. See, the 8 times negative 2x is negative 16x. Don't forget to carry those negatives through. 4 times 3 is 12. 4 times negative 5x is negative 20x. And then we just keep the 4x over there. What should we do next, though? Yeah.
Add all the x's.
Yeah. Let's combine like terms, okay? So on the left side, we can leave that alone. On the right side, we should do the negative 20x plus the 4x. Do you see those? The negative 20x and the 4x. That makes a negative 16x. Okay. Some of you already see what's going on here. Do you see two things that are the same on each side? On either side, I should say.
16.
Yeah, there's two negative 16x's. Which one should I add first? Does it matter? No. But look what happens. I add 16x to both sides, and now they go away, because they both make 0, right? So now I get 32, and that does not equal 12. So what is this called?
No solution.
No solution, or null set, or if you really like to abbreviate like I do, you could just put the 0 with the line through it, which means no solution. Have you learned that notation before? In 7th grade? The 0 with the line? No? Well, now you have it.
I knew it before. I
Good.
didn't learn it in 7th grade.
So maybe you learned it in elementary? You just learned it on PBS,
Hard on to it.
watching Wildcrats,
No,
watching Sid the Science Kid.
I'm not that young.
All right. I still go home and watch Wildcrats. It's really good. No, we're not done.
As a kid,
Any questions on the no solution? If you guys get to this point, like right there, and you see this negative 16x, you already know you're going to get no solution if these numbers are different, right? What if the numbers are the same right there? It'd be identity or infinite or everything. Okay? So let's do another one. Just for fun. This is the last thing in your notes. Last example. And you can't see it yet. All right, so we have another one of these distributing things, these monsters, although this one looks a little bit nicer, doesn't it? Does that one look nicer? Yeah. So we do rainbows. Don't forget about your negative. There's a -2 there. See it? Do your rainbows. You should get that. Somebody already saw the answer. I know it. They saw it. Right after they wrote it down. Do I have exactly the same thing on both sides? It's in different order, but is it the same?
No.
Are you sure? I have 18 and 18. I have -12x and -12x.
Yeah.
So what should the answer be? Dun dun dun. You can put all numbers if you want to abbreviate. Infinite means all, right? Meaning forever and ever and ever. Yes?
So in this homework, we just say what it is, not what the X we say.
It depends. Sometimes you'll get the one solution. Sometimes you'll get the null set, and sometimes you'll get the alls. Yeah.
Put like the infinite symbol.
Okay.
Yeah. That's an 8.
It's just an 8 laying down.
That's right.
I can't do it.
I'll take that. But just so you know, on the test, it won't be the symbol. So be careful that you know what it means. Okay, so you have to try this one. There's only one for you to try.
I thought that was the last thing.
And, well, you know,
That's what you said.
if you get this right, it's the last thing.
Okay.
If everyone gets it right,
Everyone get it right.
shh, you can get it.
No, I know I was getting it.
You can get it. Go.
I'm trusting on the top base.
If everyone gets that one right, we can move on.
How about if everyone gets that right, we have no homework?
No.
Yes.
Love that you
How about you just work?